So today I'm going to talk about a recent research project where we used classroom videos to measure teacher responses to disruptions in the classroom, kind of getting at the question of classroom climate, but not directly measuring it, kind of a proxy, a middle ground, you might call it. We're on our way to getting there, but first we want to see a very specific context in this very common version of education research where we record classrooms. The next part and the main focus of the presentation is going to be a talk about using Cohen's kappa to describe coder agreement, especially in qualitative video research, like we see a lot in education. And I'm going to start off with a cute little metaphor. Kai was just talking to me about this a couple weeks ago, and I thought, oh, this is perfect, and get people on board with this. So we have two people. We're in the woods, but it's dark. So we each have our own flashlight, and we'll have a little circle illuminating just part of the woods at a time. I see and pay attention to what's in my circle of light. I can't see anything else. And if I want to pay attention to something elsewhere on the screen, I just move my flashlight. So it's very based on my attention, and it's very self-directed. I get to choose. So we're on the lookout for animals is the story. And when we find them, we need to identify first, oh, yep, that's an animal. And then what kind of animal it is. Right? We know there are only a couple animals in this particular forest. So in this example, I look around, eventually I find a deer. Yep, it's an animal. Stop moving my flashlight, pay attention to the animal for a second, and identify. I'm not a biologist or anything, but it's close enough to a deer, right? Broad categories here. So moving on, right, we're comparing two coders. And so for this metaphor, now we have two coders. We have the yellow coder. I don't know if you can really see it, but the flashlight is illuminated with a yellow ring and the red ring. And so they're looking at different things. And eventually one coder finds the raccoon, and another coder looking at a different part of the screen or a different part of the field of vision, the forest, finds the deer. So we have this fundamental question for all coded research like this. Are they in disagreement? Of course, from a researcher's perspective, I don't want to shoot myself in the foot and say, nope, they're not in agreement. The whole project is bunk. Because we know neither of them are wrong, right? The person who saw the raccoon definitely saw a raccoon. We can see that when we review the data. And the person who saw the deer definitely saw a deer. And we can assume, we can probably actually do a smaller research study on this part, but we can reasonably assume that we trained our coders really well. And if we take that red coder and instead force them to look at the deer, they're going to say, yeah, that's a deer. And they'll probably even say the other way around, if we take the yellow coder and have them look at the raccoon. We trust that that's what's going on because we train our coders really well. Or at least all researchers would like to think so. But then, of course, there are other animals in the forest that we're not seeing at all because we're focused on that. And so there's this fundamental limit to practicality, really, in measuring reliability in video research. We're going to get the big misbehaviors in a classroom. And sometimes there are two competing misbehaviors for attention, and we get two coders to, at the same exact timestamp, code different misbehaviors. But then we're sometimes going to be missing another misbehavior entirely. And from the viewpoint of practicality, we're not going to have the coders assume that there are 15 misbehaviors happening simultaneously for the whole video, right? The video is already a class period. We don't want them to see the raccoon and then back it up and look at a different part of the screen. We just want to measure the data. We just want to measure the reliability for the data we have. So here's a very entry-level clip where we only have 2 concurrent misbehaviors. This is our actual research paradigm now. So most clips have more than 2 simultaneous misbehaviors. But here on the first playthrough, I'm going to have us pay attention to the student in orange.
Just because I'm not very good at drawing feet, you're not going to be able to make a story out of that, really. At least I don't think so. Hey guys, come on in. I don't know if you're going to be able to make a story out of that because, you know, it's just feet. I think I could make a story a lot easier out of she's a farmer, she has animals. Those are things I can make a story from.
Okay, so he's clearly zoning out, right? Total space cadet, off-task behavior. And if one coder catches that, that's what they're going to write down, right? Student 16, off-task. This second playthrough, I want to draw your attention to the kid in the navy shirt and the black hat.
Just because I'm not very good at drawing feet, you're not going to be able to make a story out of that, really. At least I don't think so. Hey guys, come on in. I don't know if you're going to be able to make a story out of that because, you know, it's just feet. I think I could make a story a lot easier out of she's a farmer, she has animals.
Okay, so besides being in a pandemic now, looking back and thinking, oh God, that's so gross. We could see this is very fidgety behavior. And so per our research paradigm, we would code this as well. And neither of our coders are incorrect if we had one focus on the orange student and one focus on the baseball cap student. We could easily imagine—
just because I'm not very good at drawing feet—
that this is coming from just 2 coders watching different parts of the room. So a little animation, following their eyes. The yellow coder is looking at that girl, moving around, and finally catches him, pretend the video is playing. And then the red coder is looking around that side of the room and rolls around to that kid in the baseball cap. Right? They're both doing their job, and they're both doing a good job of doing their job. Right? So this brings us to the same questions that I had for the metaphor of the flashlight in the woods. So our conclusion for whether they're in disagreement is very complicated then, right? They've both done their job. They're not wrong. Both of these, right, from my expert, I trained the coders, I get to decide if they were right or not, viewpoint, they caught misbehaviors. Good job. And they classified the behaviors correctly. And we can reasonably assume that since we did such a good job training them, that if the yellow coder was looking at the baseball cap kid, he would have the same exact code, right? And vice versa. So before I move on, do we have any questions about the paradigm? I want to make sure that part's clear before I get into the methods of it all.
I'm not seeing any, Blake.
Okay. Great.
I thought somebody would ask which misbehavior is the deer and which misbehavior is the mouse.
I would say in this metaphor, the mouse is, I won't show you the video again, but the student with 87 is talking to the person across from her. And our videos aren't, the microphone is meant to pick up all the sound in the room, not just right in front of them. So it's something that could easily be missed.
It might be worthwhile mentioning that in total, we basically code 7 misbehaviors.
Oh, 7 types of misbehaviors, yeah. Mm-hmm. So students can be talking, they can be off task, zoning out like orange, they can be fidgeting like baseball cap, they could be calling out, so not raising their hand before participating. They could be obnoxiously raising their hand, standing up and saying, oh, call on me. They're really excited to participate, that's great, but they're not following the norms. They're misbehaving as far as the teacher is concerned.
And talking.
Mm-hmm.
It looks like we do have a question from Carl.
Okay.
So going back to the video, I guess my wife walked by, so I might have missed you mentioning this, but do coders just watch the video once, or are they able to go back through and rewatch? So from my experience as a coach, one of my favorite sayings is,
I don't think we can hear you, Carl.
Now you're back.
All right, can you hear me now?
With an echo.
Okay, sorry. Yeah, let me see if I can grab my backup headphones real quick. Sorry. All right, how's that? Cool. So, did you hear me at all, or no?
We got through up until your coach example. Then we didn't hear the end of it.
Yeah. So with the Adams Guy Does Not Lie, basically, like we'll go back and rewatch it, and then when I'm watching film, I watch each play for each individual player. So it like takes a lot of time when I'm running film, but I'm going through and like making sure I'm identifying, like watching what each player does, and then I'm scoring them and then providing that as feedback. In this sort of situation where you have, like 18 subjects, like do they go through and code each one and then tie that to the child, or no?
Right. So they have the option to back up whenever they want. And that's one of the most important parts for comparing these misbehaviors. We want to compare the timestamp, right? We're going to have an algorithm compare to give us our reliability. And so they do back up and they see, oh, exactly what time did orange start being off task? And that's a little nebulous, but they get close enough for our statistics package to pick it up. To answer your question about watching each individual student, though, we're trying to balance, of course, the practicality of how many hours do we have as a researcher. We're already borrowing a team of 15 coders time, and we're getting a fair number of misbehaviors already, and we're getting to the I guess the reasonableness of the project, right? We want it to be we want it to reflect what the teacher is seeing, because the other half of this project then is the teacher is wearing a mobile eye tracking system. And we want to see how they respond to the misbehaviors if they saw the misbehaviors. And so if we're not seeing it when we're watching it at about half speed, effectively on average, the teacher is likely not seeing it. And so for the purposes of the project and for the purposes of really mapping our what we've turned into lab research into very applicable, very applied research of what's the actual definition of misbehavior in the classroom in real time. We don't have to focus on individual students one at a time. And I like your coaching metaphor. It reminds me of how we train referees. We do go through each play and rewind and start from the very beginning and say, okay, now through the whole scene, what do you see? Is this foul or that foul? Is it not a foul at all? And do you give a card, or do you, et cetera? But we all know while we're doing that training that in real life, as a referee, or in a classroom as a teacher, you only get one shot. And so we want it to be, we want to have a balance of catching everything the teacher could have seen and responded to, while also not taking up too many RA hours and not making it too far away from the real world. Does that answer the question?
And Carl, you are exactly on the money. That's exactly the problem. The complexity of this measurement situation is much more difficult than we initially thought. And that is a good segue, to the next slide.
Mm-hmm.
Because now think about this, we want to publish this, and what reviewers always ask when you have two raters, they want to hear, what is the interrater reliability? You have to come up with a number, and that is exactly where we have the problem.
And so one of the most common ways of doing this, at least in the past, was to just get the simple proportion of agreement. And so we're looking at the middle column here. So we have one judge who is choosing between 3 categories, and then another judge who's choosing between the same exact categories. They can only choose one category for each event that they see. All the highlighted things are when they are in agreement. So this is all the times when judge 1 picked category 1 and judge 2 also picked category 1 for the same event. And then this category 2, category 1 is a mismatch. It happened 2 times. And so like in our real data, it's much more common for them to agree. We put this on top, and we just divide it by the total number of events that we coded. And we'll come back to this 83% later, but simple proportion says that we agree by 83%. But Cohen says that there's a big problem here. We haven't corrected for the likelihood that judge 1 will pick category 1 just by random. There is a propensity for judge 1 to pick category 1 over category 3. We can see that with the numbers. Category 3 was chosen by judge 1 13 times. Category 1 was chosen 27 times. So we need to account for the fact that judge 1 is twice as likely to pick category 1 over category 3. And then same thing, judge 2 is also much more likely to pick category 1 over category 3. Right? This is 28 to 14. And so of course this number is biggest in category 1 agreement. Half, if not more, of all of their codes are in category 1. So there are some requirements for kappa according to Cohen, but the most important idea here is that we're looking at the percentages. We're looking at how likely it is that judge 1 or judge 2 is to pick category 1, 2, or 3. Everything else, ignored for now. So I do want to get into the weeds for just a minute or two because it is methods hour. So here's our old friend proportionate agreement. Here, it shows up in the kappa equation, so it plays its role. But we also want to look at the probability of them just randomly agreeing by chance, based on their propensity to pick category 1, 2, or 3. And so same exact calculation here, PO, it's all the on diagonals, we call it. That gets us the same 50 out of 60. But then we also want to look at the probability of agreement. So PE is the total amount of agreement. So we add up the chance of random agreement for each of the 3 categories. The example I've drawn out in long form for you is category 1. We take all the times that's picked per judge 1, 27, over all the times they picked anything, and we get there, 45% of the time they're picking category 1. And same thing for judge 2, 47% of the time. So judge 2 is a little bit more likely to pick category 1 than judge 1 is, perhaps negligibly, but we're going to throw it into the equation. So we do this for all 3, find out that the probability of random agreement is 36% of the time. They're going to just happen to agree. So we need to account for that. And we get that kappa is now lower than our just proportionate agreement. Our old proportionate agreement was 83%, but when we account for the fact that 36% of the time they're just going to agree by chance, this kappa statistic, which ranges from 0 to 1, and excellent agreement is 0.8 and above. Right? It's another nebulous part of this metaphorical equation. But we're close to excellent agreement. We're up there in what would be okay per Cohen based on his writings, but we probably know based on experience trying to publish that this would be a pretty difficult thing to get past the reviewers without a good explanation like we have, or like most people are going to have, right? You're going to want to combine this with other tidbits of knowledge about your exact paradigm. Just a quick thought experiment. If we take our original numbers and if we inflate the proportionate agreement and keep the probability of randomly agreeing the same, our kappa goes way up. If we instead decrease it from our original number and keep the probability the same, our kappa goes way down. It's not just a matter of, oh, we lost these 0.3, we're going to lose 0.3 in kappa. We lose much more than 0.3 in kappa. If we keep the proportionate agreement the same, this green number all the way across, and we instead raise the likelihood that we randomly agree, our kappa takes a hit. That makes sense, because not all of this proportionate agreement is coming from true agreement. It's just coming from the fact that I really like picking category 1, and so does my friend. And if we lower that, of course, our kappa goes up. But see, I've lowered it a lot here, this chance agreement. And so the best thing to do to raise your kappa is to raise your proportionate agreement. And so we're not too far from the original way of comparing coders. We're just being a little more mindful of our chances of randomly agreeing.
Blake, I think we have a question from Lee.
Yeah, I wanted to ask if, and I haven't really worked in this kind of space before, and so I don't have much experience with kappa, but in a sense, is this kind of punishing you for having like a really easily identified category or like really clearly defined categories where you'd have this agreement because you should, even if it's random, but the random might not be random? Does that make sense?
Right. Well, I'll let Kai think about that a little more, but my initial response is that you're not being punished for agreement per se. If we had a really good paradigm here, like you're saying, we had really well thought out examples, which of course I think we do for our project, we would have our judges agreeing a lot, right? Ignoring the rat problem in the forest. And the deer raccoon, right? We're pretending that that's not a problem for now, just to give us a crash course on kappa. But then this would be 27, right? Instead of 25, 2, and 1. And this would be 27 instead of 25, 1, and 1. I didn't do the math right, but this would all be in there. They would agree 27 times, right? Because that's the lower number here. And so you would inflate your diagonals here. If you had a better paradigm, you'd have less disagreement, right? It wouldn't change your propensity to pick category 1 as judge 1, right? It would just suck up this 1 from category 3 and this 1 from category 2, and it would be placed into 27. If I understand your idea correctly about it being a well-defined coding scheme. Yeah,
and yes, and then also just if like say category 1 is just like more frequent. So like you have both reviewers picking category 1 most because it's like a clear example and possibly more frequent. Mm-hmm. Would that cause you to have a lower kappa value even though it just really they're doing their job correctly?
If it is a very common category and they disagree on it, then yes, it would hinder kappa. But if it's a really common category and we're just inflating, we'll call it cell 1, right, A1, then we are in minute steps just inflating PO. And we saw on this table, if we increase PO, obviously it's not going to go up by 0.15 by making category 1 more popular or likely to show up. But it'll be going up and going up more than the PE going down makes the kappa go down. That makes sense?
So Lee, I think it's, the intuition of Cohen's kappa is very simple to explain. Let's say you and I would look out of the window and something is moving. And we have only the decision, is that a UFO or is it a bird? So you would probably say a bird, and I would probably say a bird, because the probability of a UFO is close to, depending on where you stand, let's say it's very close to 0. So we will have extreme agreement because we will always say default would be bird. And it would, you would think, wow, we have so much in agreement. In 99% of the cases, we're in agreement. And even Adrian would be in 100%, almost 100% agreement with us, and she doesn't even look out of the window. I would just say, oh, what do you think is outside the window? And Adrian would say, probably a bird. Oh, but it could also be a UFO. What do you think about that? No, it was not a UFO. Right? And the statistic should not measure that in this case, basically just random knowledge of the world, causes agreement. It's particularly important for more rare events. In our case, one could argue because there's not much world knowledge. You would not, I mean, I know our data very well. If Blake would say to me, hey, Kai, here's a misbehavior, and I'm blindfolded, I would say it's probably talking, because I know what the marginal probabilities are that is the most common or off task. I know that. And then, of course, our coders, they pick up on that also very quickly. So they do develop, a marginal probability, which is basically, a proportion that you would have as a default.
Thanks. It seems like we also have a question from Yongji.
Hi, thank you for the great talk. So I wanted to add to Lee's question about kappas being like punishing the frequency difference between the categories, because I thought, and then Blake somehow said if the agreement rate is still high, it shouldn't be a problem. But from my understanding, since we have a study that used observational scheme, and then we had the kappa, but the issue was that our category, the behavior observation, yes and no, and then yes was like uncomparably low, then so 1 was incomparably low than 0. And then I was looking for literatures, and then they were talking about this weighted kappa, which is like fixing the kappa's issue of being low for rarer categories compared to the other categories. So even though they have the same proportional agreement, if the category 1 and 2 are disproportionately large and small, and the kappa will be like only half of what it's gonna be. So I was wondering what you think of this. And then it was kind of hard, or so I was trying to read about the weighted kappa, and then the issue was that for 2 by 2, 3 by 3, so depending on the number of categories, the solution was just too complicated. There were too many different options. So even though we had 2 categories, there was 9, which we couldn't really clearly see the video or the facial expression of the observed individual. So I was wondering also if you had any of those 9 categories, which is really rarely occur, and then totally mess up with the kappa because one coder said 1 as a 9, but the other was not. So basically there is a 3rd category, but the 3rd category only happened once, and once by the one coder, which is not a huge difference from 0 from the other coder, but still kappa was like just so low.
So this is a good segue into the next slide. But first, I'll answer half, or I guess.
Let me just one thing. What I think is very important. What Young-Hee is asking here. One of the big problems is that somehow reviewers or in research, we always want one number, right? We want, and we don't know what it really means. And in your case, or in our case, sometimes it might be good in the appendix, just give me the 9 by 9 matrix, right? That I can see, also what were the typical distractors, where is the disagreement, because it's not the non-matches are typically not evenly distributed, and that might convey way more information than one single number, which has, only a very limited meaning. So this is really one of the big take-home points for me from today, is one has to be really careful in a tendency. We are pushed, our field pushes us, give me the interrater reliability, give me a number. and the number should better be high. And we all kind of tweak our data until we get the Cohen's kappa to 0.80 and sweep under the rug all the real problems of our coding.
Totally agree. Thank you for saying that, because we just got rejected saying the kappa is too low, that when human rate is great. So I was so mad, and then trying to find how to navigate this.
So you mentioned for a second about the propensity at the very beginning, and you got into a good point about weighted kappa, which we'll talk about in a second. But just a quick thought experiment around if there's a true value, right, around which one should be the most common. Ours was talking, we'll call it. But if one judge, based on their codes, has said, well, actually, talking is not the most common misbehavior. It's X or Y instead. It's going to double hurt them, right? It's going to change their propensities, their PE, and it's also going to really hinder their number of lineups just by a factor of the denominator, right? And so their PO is also going to go down. But to answer your weighted kappa, I'll pass it off to Kai here.
Yeah, and I want to make that quick because I want to come to our final point. Blake, you might still have to be my slide mover, right? So there were a couple of generalizations of Cohen's kappa. The first one was he did it himself, 1968, and that is the weighted categories that you were mentioning, and that was an important change because that allowed to weigh by how far the disagreement is. Cohen did develop this for clinical psychology for diagnoses, and of course some of the diagnoses between whether you are psychotic or well, some of the diagnoses they are more overlap, and it's more likely that you would disagree, but that disagreement is not as bad as other disagreements. So that's where the weighted categories come in. What is interesting to us for our problem is Fleiss kappa, that is generalization to more than 2 raters. And interestingly, when you look at this, you unpack the formula for Fleiss, like, oh, okay, we should just throwing those matrices, this 2 by 2 matrices all together and summing them up. And that is actually the same what the most commonly used in complex situations is Krippendorff's alpha. It's also a little dated. But Krippendorff had something that I thought, oh, this is going to help us, because Krippendorff's alpha is famous for dealing with missing. When you have missing information, I thought, oh, this is exactly what we have, because if my flashlight shines on the deer and yours shines on something else, another animal, then of course, there is missing on your side for my deer. I said, oh, okay, that is perfect. The problem is with that is we only have 2 coders. We could have taken big advantage of Krippendorff's alpha if we had more than 2 coders. So 3 coders would be more, because then there's a chance that 2 coders actually really see the same misbehavior. So the problem is, and just to, not go into too much detail, so I leave that out, it's not important. Our problem is, Blake, can you go back and just show one of the original Cohen's matrices? No, go backwards. Yeah, that's good, that's good. So you see this when we have, our problem is coming back to the beginning with our deer and mice and raccoons. So you see the category 1 of judge 1 and category 2 of judge 2 or 3, we don't know whether they are really in disagreement or they just shine their flashlight on a different spot. Right? We don't know. So we have now, the first step has to be, we have to make sure they are really looking at the same spot in the classroom. And so this is a challenge, and therefore we after really weeks and months of looking, there is no statistic that helps me with that. So here's now the data. These are really our data. And I'm yelling because I still get an echo. Me on my own. No. And so you see that where it's highlighted, this is where I decided, oh, this is an agreement. This is now the time. There's, time 1, this is now covered, but if you look at time 2, this is the time in seconds throughout the 45-minute video. This is the first 10 minutes. And you see the first 2, both coders, this is very close in time, and both OT is off task, and this is the same student. So I can now, having the data, I have to decide from the codes, do they have the flashlight on the same misbehavior or not? So I look at the coders. This is very tedious to do by hand. You see, I have to, you see in the third row, there's at 2:02 seconds, well, the student was not identified, for some reason the camera was off camera, but it was an off-task behavior. And I have no partner from the other coder. So that I have missing for coder 1. And if you go down, for time 1 at 237 seconds, there's the opposite. So my coder sees student 18 doing off task, and my coder 2 sees nothing. So for all these where there is mismatch in terms of the flashlight, then I can't use this to calculate Cohen's kappa. So now we have really, you see already my problem. I have more white than I have orange. So I can calculate Cohen's kappa. And if I do this, I get a Cohen's kappa of, what was it, Blake, 0.83 or something. So now I'm tempted, if you submit this for publication, I keep my mouth shut. I report that Cohen's kappa because the reviewers want the Cohen's kappa. But it's based on only 20% of my data. And I'm somehow stuck. This is my question, how to do this creatively. I'm one step further. And so one thing that bugged me is, of course, I have no algorithm to decide what is a match and what is a mismatch. So what I do, if I do this by hand, I look at the time code. Well, the time code could be a little off because when an off-task behavior starts and when it ends, it's hard to see in the video. So there has to be flexibility for that already with a time code, right? We told the coders to define the onset, but even that you could be in disagreement, and that's not important to me. They don't have to be 100% in agreement about the time when it starts, right? So, but I did this by hand. What you see, I did this by hand, and I don't like that. Because I say, oh, because I have to see, oh, is it the same student? And of course, if I see already it's the same student, then I'm more flexible with the time code. And if I already can't blindfold myself not to see what misbehavior it is, it's calling out, oh my God, this must be the same behavior, although it's a minute apart. You have definitely a coda bias, or you have wishful thinking. So that problem I have resolved. You put the next slide up, Blake. Just move. Oh, yeah, 0.84, yeah. And Krippendorff's alpha, by the way, yeah, that's also funny. That is almost the same because I can't take advantage of Krippendorff because I only have 2 coders, right? And if one is missing and can't calculate that. But if I had 3, go back, sorry, go back to the deer. Yeah. So this is based on, right, that I assume they look at the same animal at the same time. Okay, so next slide. So what we did do, was able to create an algorithm in SPSS. You could do this in RCode too. This is only the first half of it. So I'm able, if you go back one slide now. So what the algorithm does is it looks at, for each, it sorts those. I have this all in one file, and I say, well, go to the last incident that is coded before and see, is it the same, is it a different coder, but it's the same student, then make that a match. And I go back and I can define how tolerant I am with the terms of the time window. So my algorithm defines, is it, right now I have it very liberal. I have almost 30 seconds in both directions. If I have a misbehavior that was coded by my first coder, then I look at the second coder's data 30 seconds behind and 30 seconds before, and see whether I find the same student identified as misbehaving. That sounds very liberal, but I actually get even less. I only get 15% agreements with my algorithm. But I personally, and Adrian is nodding, so I'm a person, I love to have an algorithm rather than having, we did this by hand and we agree, I don't like that. I rather have a clear definition, what I count as a match. So that problem I feel we were able to solve. But our open question is what to do about the fact that I'm only talking about 15 to 20% of my data.
Great. So I think we're pushing up on time here. So we can definitely keep this open and keep the conversation going. There's students.
Hey, I just want my answer. Time's up. Give me the answer now.
Right. Do it, Kai. Do it, Kai.
I really, here we had questions. What's the better way?
Perfect. So folks, yeah, please hang around. We can explore this together. I just wanted to make sure if you had anything else pressing you wanted to say, Kai and Blake, now would be the time, and we can hold this open for discussion. But just wanted to make sure we properly covered things and thanked you as a full group first. So. Okay, so we have a bunch of questions in both the chat and hand raised. I see Sonia has her hand raised and Yongji has some questions in the chat. So let's go with the hand raised first.
Hi, so this is really interesting and a problem that I never have thought about as someone who's familiar with media content analysis, that you would not just watch the thing over and over again. So I have two questions. One has to do with sample bias and whether that's an issue in what you're trying to accomplish with the data in the end. And the other is whether you're able to establish kappa, I guess this goes to your point too, that's up on the slide, by having coders rate some subset of identified situations. And I think you mentioned something about these being relevant to like what the teacher does. Could you select instances that the teacher responds to and then focus your coding on those things? I mean, it just seems like there's a lot of potential for some bias here about what's noticed and what's not noticed, but perhaps that's your point.
It is, yeah. And of course, for us, I have more in mind, the next brand I'm applying for, because the ship has sailed, we have coded the data. We're not going to go back and, we have no money to do it again. But it's more, if I were now to apply for a grant, what would I propose? What you are referring to, what is really a problem is we don't know what the base rate is of misbehavior we see in 45 minutes. And if you ever been in front of a classroom, a 7th grade classroom, wow, there's a lot. Even only our categories, right? We're not picking nose or something, minor infractions that chewing gum, we don't know. That's often also would be misbehavior depending on the teacher. So this is a problem, but you're right, we do not care necessarily about the absolute number. And the problem is whether it's the bias or not. I would say we treat this, what our coders identify as random. So if I had 20 coders, I probably would reach the total number of misbehaviors in the classroom. But our metaphor with the flashlight is the flashlight goes through the woods, randomly, more or less, or it's only what is most, if it draws attention, then it would also draw the teacher's attention, right? So our misbehaviors are not equally bad. Little fidgeting under the table that we don't see, the teacher doesn't see, we would not really care. But I'm responding to this bias. I don't think there's much of bias, only in terms of the absolute number, then yes. But in terms of what misbehavior is biased,
I'm thinking about this in the context of, and this is not my area, so if I'm incorrect here, please correct me, but that certain children are called out for misbehavior more often than others. And that there's racial bias, for example, in what's considered an infraction or isn't. And so if the coders are acting as the teachers would, then maybe that's not a problem. But it also goes to the question of like what actually is happening in the classroom, right? So I'm thinking less about did you catch them all and more about did you catch certain ones more or less than others, and is that a systematic effect?
Yeah, I like that point. That was, I took like a part of this and did a gender and race analysis for my my part of the project, and that's a really good point. And even though we're telling them to, you know, approximate the situation of, you know, we're watching this and treating it like an experiment on classroom climate and what's happening in real life with the teacher, we still find that there are different likelihoods of different genders and races committing different misbehaviors. And it doesn't reflect the same likelihood of teachers catching the different types of misbehaviors or responding to. They're all different frequent histograms. And so, yes, we are not accounting for that bias, but we're still seeing a difference there. And so the difference is probably more stark. I totally agree with that. But even with this paradigm, we're catching a little bit of that nuance and saying, hey, teachers are seeing it differently in their head than how it's actually playing out in the classroom, to an extent.
In solving the problem, it'd be helpful for me to think about how do you plan to use these data? Like what data go into the next analysis? What are you taking from these codes?
Yes, for example, I mean, we take this and compare this what the teacher actually sees. What you have to understand is the coders, they code from 1 or 2 stationary cameras that capture all the students all the time, right? While the teacher, of course, she only sees, we know what she's looking at. So we contrast what we think is objectively happening with all its limitation compared in contrast to what the teacher is looking, where the teacher has their attention and how they respond to the misbehavior. That is then, of course, key. So for us, that's what I was trying to say to Sonia's, comment. So if we only have a subsample, we only catch, let's say 50% with the video coding, I don't mind that as long as it is really not overly biased from the side of the coder. So there is a limitation. Blake and I talked about this. We have, for example, no minority coder. So we have, our coders are all white undergraduates. But.
So to answer a little bit more of your question, Adrian, there are more data than what we show you here. This is just for the purpose of reliability. But for each line item, we also have, instead of these columns, right, we have from the mobile eye tracking video, did the teacher see student 12? Oh, that's not a straight line. But for this top line, did the teacher see it? Yes or no? Based on the mobile eye tracking, what was the teacher's response? Did they reprimand the student? Did they address the class? Instead of saying, Johnny, you're a terrible person, they could just say, oh, class, we need to raise our hands. Stop acting a fool. Or they could, respond positively. Oh, great, thanks for participating. I was worried nobody was going to answer my question at all. And there are 2 or 3 other things, but those are the main things. And so we have it not lined up this way, basically. We take the first round of codes. And so as Sonia was saying earlier in the chat, it's a sampling. And so by the end of the semester, we'll have a full first round of codes and a full second round of codes. And Kai and I are really excited about just running those 2, running the second round of codes with the same exact
syntax.
Thanks. Yeah. And seeing, are the results thematically the same? Are they statistically exactly the same? Our hunch is that they're going to be pretty close.
So my starting point, Adrian, was we get, if I would really do naively Cronbach's alpha, Cohen's kappa, we get a shitty Cohen's kappa, right? You know, if I were to, whether it's missing, I would say not the category. Or I would have missing as an additional category. It would be awful. But at the same time, if I do it with my first codes and then do my data analysis with respect to the teacher effects, for example, and then I run it with the second set of codes, despite the fact that Cohen's kappa is so low, we will get exactly the same effects, which to me, you know, the conclusion would be the best is to actually really combine them, right? So I have the first 20 identified by coda 1 and the second set of 20 identified by coda 2 with an overlap of 5. But they two together, they accumulate actually the misbehavior that is seen. If I take just one coder, I get, you know, randomly, you know, that misbehavior or the other misbehavior, but the effects I see with respect to the teacher behavior is the same. And the teacher behavior is student for us.
Yeah, I have a thought, but anything else from attendees? No. Yeah, it seems to me that if recoding isn't an option to increase reliability, or retrain or add a third coder or whatnot, then your approach of just focusing on when you have overlap and being transparent about the randomness of the process and potential bias in that might be the way to go. And you can use the algorithm for cases where you can define that overlap, but transparency about the process and making sure reviewers and readers understand like what you're trying to capture from the random approach just has to be paramount. We have a question from...
We'll come back, Adrian, when we get the first round of reviews, what reviewers say, whether they are so nice like you are. We'll heed your advice and see where we get.
You don't have to do that.
No, I like your advice. It's actually, Blake can confirm that's exactly what I want to do too.
We have another question from Emmanuel.
Yes, hi Kai, hi Blake. Great presentation. We have a question about the denominator in your analysis. Are you like calculating it at the second level? Are you chunking the video up at a bigger intervals? And then as a follow-up is, my understanding of Cohen's kappa is that each code needs to be independent from the other ones. How are you thinking about that within a video? Because I would imagine that a code for a second number 25 might be due to second number 24 once you have recognized that there is a misbehavior. So those stop to be independent. And I don't know how to think about it within an agreement framework.
Blake, say something. No, I mean, the independence is a problem, but it's a pseudo problem for me because there is no statistical inference, right? There is no statistical. I mean, Cohen's kappa, you could, it comes with a standard area, so you could do significance testing, but the independence would be a particular problem if somehow you use the sample size as for inferential purposes, which we don't. So I'm not really worried about that because of course it's more likely if you have talking of student 12 and then the next misbehavior is talking from student 13 who's just responding to student 12. Of course it is technically dependent. You are totally right to that. But again, that I'm not so concerned about because there's no inferential statistic.
Can you say more about your denominator question? Do you mean like the actual denominator or like the spiritual denominator? Because I have an answer for the second.
I'm just wondering what is your like unit of analysis, if it's like at the second level, 5 seconds interval, because then I'm thinking about, the percentage, the random percentage of agreement, or, the EPE, and whether that might, be inflated or deflated depending on the chunk that you decide to use. I don't know if that makes any sense. So, like if you're watching a, 10-minute clip, there are what, 600 seconds? Mm-hmm. But if you chunk it into minutes, for example, it's just, 6 minutes or whatever, 10 minutes. And that might change artificially your denominator and numerator. I don't know if that makes any sense.
It does make sense. For us, it's the unit is definitely the misbehavior, more or less disregarding how long it actually is. This is where the ambiguity comes in. And here again, it has to do with what the project is mainly looking at, namely, has the teacher seen it or not, and how did she respond? So then having bigger chunks makes no sense because the response of a teacher is typically immediate to the misbehavior itself. But I see your point in other contexts that might be actually a little bit, having aggregation could be actually a good thing to stabilize the results. I totally agree.
Thank you.
So unfortunately, I have to leave. I'm late for my next meeting, but you guys keep chatting. Blake can answer all the questions. I'm sure.
Great. Thank you for your time, Kai.
Hey, that was fun. And if anybody has more ideas, email me or Blake, any input appreciated. Or you find a paper where they discuss the same issue. This is also, nobody can really see everything.
Perfect. Yes. All right.
Bye-bye.
So long, Kai. Any other questions in the group for Blake? Okay, well then I guess we can set you free, Blake. Thank you so much for sharing your work. Students in the class, you can hang on here for a few more minutes, and others, please go enjoy your weekend, and we'll see you back in a couple weeks for the next Methods Hour.